Scientific notation. This video will cover one of the skills that you're required to demonstrate throughout the year and in every topic, and that's scientific notation. So there are many systems of units in the world, and you might have come up with one yourself, but the main ones that you would have heard of are the metric system and the imperial system of measurement. In order for scientists to communicate efficiently and effectively with each other around the world, an international system of units has been agreed upon, where scientists use this system in all their work. So as scientists, in order to communicate effectively, we'll may need to do conversions in our work to ensure that our work is in scientific notation. Some of the common conventions that we use, and by convention I mean just the way we do things, is that no matter what we're talking about in terms of distance, whether it's a distance between atoms or distance to the sun, we use meters. With mass, we always use kilograms, and with time, we always use seconds. For the others, I'll go through them as the course continues. A conversion of units often involves multiplying or dividing a number and then changing the unit definition at the end. So the example that we've got on the screen is converting 1 mile to kilometers. And if you multiply 1 mile by 1.6, this results in the conversion from miles to kilometers. In the white box on this screen, you can see that both the numbers and the units themselves are located in the bracket in the middle of the equation. So in this example, we're looking at converting inches to centimeters, and in 1 inch, there's 2.54 centimeters. So you can see the units here in the brackets, we've got inches and centimeters per inch. Now our final result, when we're doing this conversion, is to multiply the numbers. That's easy enough. But with the units, what we've got inches here and centimeters per inch here, and we can actually cancel out the inches, as we have 1 as the numerator, 1 as the denominator, and then they cancel out. So the only units that we're left with is centimeters. By putting in the numbers and the units themselves into that equation, you can ensure that you get the correct result in the end. Now when we're talking about physics, because it's such a great science, we often deal with really small numbers and really big numbers. And when writing these numbers down, there can be a lot of zeros involved. And this can get messy and hard to keep track of, and takes up a lot of space. So when we've got numbers such as these, what's the best way to represent them? So scientists use a method called scientific notation to represent large and small numbers. And this is based on the following mathematical facts. So 10 to the power of n means that it's the number 1 with n zeros after it. So 10 to the 8 is 1 with 8 zeros. 10 to the minus n represents 1 over 10 to the n, with the minus representing the reciprocal or just flipping the fraction. And in the example of 10 to the minus 8, it results in the decimal, 7 zeros and then a 1. When we multiply a number by 10, we move the decimal to the right. And when we divide a number by 10 or multiply it by 10 to the minus something, we move the decimal to the left. When expressing numbers in scientific notation, we follow 2 rules. That is, first, we express a number between 1 and 10. And to be more specific, it's 1.000 up to 9.9999. So we can't include 10. And we multiply this by 10 to the power of something. And that something is an integer. So we've got 2 examples on this page, and I'd like you to get out your calculator and type these in just so you can see what the actual values are. If your calculator keeps it in scientific notation, I'd like you to practice just writing these down as if they were normal numbers without scientific notation. So you'll be writing down a lot of zeros. Now the first one, 6.67 times 10 to the negative 11, is a very small number. That negative in the negative 11 means it's less than 1. Now if you had the second example, which is 10 to the 15, you can see that 10 to the 15 is actually a really large number. So when you multiply it by 1.5, it's still going to be a very large number. Regarding the significant figures, you can see the significant figures video about that information. Now, again, to ease communication, we often use prefixes when we're talking about large and small numbers. And you might have experienced this without even knowing it when we're talking about speed of a car with kilometers an hour, computer memory in gigabytes and megabytes, and other examples. So this table identifies some of the common prefixes that we use when we're talking about these values, and is located on the formula sheet, so you don't need to memorize it. But you'll use them so much that you probably will. So one example that I'd like to point out is kilo, which is commonly used in kilograms and kilometers. So kilo is actually meaning 1,000 of something. So when we're talking about kilograms, it's 1,000 grams. In kilometers, it's 1,000 meters. And you can see from the prefix here, kilo represents 10 to the 3. And 10 to the 3, if you do it on a calculator, is the number 1,000. When we're looking at the powers of 10 in this table, the small numbers have a negative in them and are usually denoted by a lowercase letter. But when we look at large numbers, they have a positive index and are usually denoted with a capital letter. So this question will take a little bit of work, but I'd like you to determine the distance in meters that light travels in 1 year and use scientific notation as your final answer. And if you want an extra challenge, convert 100 kilometers an hour to meters per second. And when doing this, see if you can not only use the numbers, but the units that are involved in each of the conversions. So for example, there'll be 365 days in 1 year. So with the units there, that's 365 days over 1 year.